So we're here to talk through this TomTom puzzle I wrote called The Lonely Ones, and it's a puzzle that has a pretty obvious theme because it only has one kind of clue, but it's going to stretch your mind a bit in terms of thinking through all the ways you can fulfill that clue, and that will get you through to the logical solve. The first thing to note are these two cell cages. They must be a subtraction, and they will always be consecutive digits, 1 with 2, 2 with 3, 3 with 4, 4 with 5, 5 with 6. And so one thing to watch out for is we always need to leave, like in this column, two sets of consecutive pairs, or in this row, one kind of consecutive pair, or this won't work. So that's all we need to store at the start about the two cell cages. Three cell cages have a few more options, but in a row with a 1 in it already, this is now constrained to a particular triple. And you can think about it in two ways. First, could it be a subtraction? The way to test if it's a subtraction is to go to the largest value and the remaining small values and see, can that work? 6 minus 2 minus 3 is indeed 1, so that is a valid way that goes. If we think about this as a division, 4 only has one factor below it that you can put in a single row, which is 2, so you can't divide 4 and all of its factors, but you can take 6 and divide out 2 and 3. And we end up with either subtraction or division for this cage, but 2, 3, 6 must go here. 4, 5 goes over here. And that thinking for these three cells applies a lot in these four cells in a vertical column. In this case, we can say it's never a subtraction because 6 with 1, 2, 3 gets to 0, but it can be a division. The same 6, 2, 3 works, and dividing by 1 doesn't change the value of that division. And so this at the start also is forced to be a pair like these numbers, and at least 4 and 5 as a straggler, so don't want to be in these large cages, and forces of 4, 5 here. A thing to note because of that is actually something about the digit 1. Like 1s are the digits we can use most easily at the start, and a 4-5 cage like this can't exclude having another 1 in it. The only three cells that work without a 1 is 6, 3, and 2, so we know this one for sure. And you might have the intuition that the last large cage, these four cells, probably need a 1 in them as well. To give you an example of other extremes, we could get as many as 7, but as small as 7 for subtraction. So this value would have to be 8, which is not in this puzzle. Or as a division, this would have to be 12 to work in this puzzle. So short form of that is you do need to put 1s into these larger cages for this to work out. That gives you a 1 in one of these two cells, which isn't useful at this immediate moment in the puzzle, and the last 1 in one of those two cells. So where do we have to look? Well, we've got lots of 2-cell cages, which aren't going to be quickly resolved, but we have this 3-cell cage to think more about, and particularly if it leaves valid values for the rest of this row. And since I constructed the puzzle, I'll start with the thing to observe that cancels, which is if you put in a 5 here, you always put a 3 in here. Notice you've used all of the odd values in this row now. There is no set of 2 digits that remain that can get you a subtraction of 1. You can't make a consecutive pair. 2 of 4, 2 of 6, 4 of 6, none of those work. And so 5, 1, 3 is an impossibility in this puzzle at this stage. And we can instead put in a 4 here. That completes the 5, 4 down below. The digits that pair with this 4 can be 4 being the largest with a small subtraction with a 2, or actually 6 on the extreme being the largest, minus 4, minus 1. And so let's note that both of those take another even value. If this is a 6, you're going to leave behind a 5 with a 2, 3 pair. If this is a 2, you're going to leave behind a 3 with a 5, 6 pair. And so this cell now is forced to be odd because we have an even, even, and one of these will be even. That means this cell is also even. And that will get us thinking about, in this fourth row, where can we put what is probably the harder number to place in this grid of 5. Notice we already have a 5 that's excluded here. So question is, does 5 have to be in this cell, or can 5 be here? And in this large cage, if it's a 5, it's always going to be a subtraction. Like you could put another 5 in this box, but there's nothing else to divide here that's going to work. And 5 minus 1 minus 2 minus 2, the smallest this can be, doesn't work. It gets us down to a 0. So 5 can't be in these cells. 5 must be here. That pairs with a 6. It puts in a 2, 3 to finish this column. And we're continuing to make some progress. It's slow, but it's steady. And let's continue thinking through this large cage because it's the most distinct cage we still have left. Let's still go through that thinking. We know it's not a 6 because of the digit to the left. We just talked about why there's no 5 in this cage. That even makes us worse because now it'd have to be negative 1. 1, 2, 3 as a minimum there wouldn't work with 5 at all. Can it be a 4? Well, again, this will now have to be a subtraction. The only value I saw with a 4 before was something like this, with a division with those. And so this cell can't be a 4. And so it's left down to just being a 2 or a 3. And then if we work across what's left in this space for that, we do have a set of options. 2, 3, 4, and 6 all look okay for this space. And so we'll have to work through more to make this all work out. But one thing we can do if we track our nodes well is after we place that 6, knowing that this cell over here is a 2, 3, we've actually formed a helpful pair. And that pair puts in a 4, 5, 4, 5, and the remaining cells in the space. And if we come back to our thinking about where does a 1 go in this column, a 1 is not right next to a 4 or a 5. The 1 must be up here. That puts the last one down here. 1 pairs with 2. 2 feeds into 3 and 2. That completes this as a 6. So we're making a lot of headway here. This 2 forces this 3, forces this 2, forces this 3. We get another 4, 5 set up top. That now is going to force this to be a 3 or a 6. This is now a 2 or a 6. So coming back, this is the only space for a 3. Forces a 4, forces a 5, forces a 4. This is now a 5, 6. Let's see, it's, I think, coming down this column. This is a 4, 5, 6. This is a 5, 6. So once we actually know this is a 5, 6, it must pair with a 5, 6. That means this is the 2 with 3. It means this is 6. This must be a division to work out. Leaves a 4, leaves a 5, leaves a 6, leaves a 5, leaves a 4. Down here we get a 2, a 6, a 3, a 6, and a 5, and we're through the puzzle. So hopefully you enjoyed seeing the solve. It very much had you think through the extremes of how to make ones work in larger cages. Placing the ones was key at the start, but really seeing how the all odds set 5, 1, 3 breaks apart this row, and then tracking 5s around the grid in different extremes, eventually getting a key pair here, this 4, 5 cell to get that one up there. So hopefully a good example for the harder TomToms of how to at least know which cages are most constrained and take some values across the grid to think through them. Hope you enjoyed watching this video, and we'll see you again soon.